Thanks everyone for joining. This is the first of our webinar series. We want to pick topics which are extremely relevant, which is what people in the industry are talking about and thinking about. Today we're gonna cover a topic which a lot of people have asked us to present about. It's secrets to slashing data platform costs by 30%. This isn't 2021, 2022, where we have open checks and being able to go invest with large infrastructure projects as well as large teams. Cost is on everyone's mind, given a big focus in the macroeconomic climate around profitability. CFOs often have a lot of pressure on data teams to cut costs. So what we wanted to focus on today are some very practical aspects as to how you lower your data platform usage and spend. This talk is going to be quite different from a lot of very traditional cost optimization talks. So we're going to cover what are the different components when it comes to your data platform builds, when it comes to your data platform costs. So we're going to look at a few different things. And we're also going to have some time to go look at some industry trends and really where the space is headed. A little bit of background on myself. I've been in the data field for over a decade. Got to be one of the first data engineers at Salesforce.com back in 2011. Most recently, I ran the data group at WeWork. We built over 100-person data group, supported over 12,000 employees. 4 years ago, I quit to go build 5X. What 5X is we are an all-in-one data platform, which makes it very simple for companies to get started with data. Yeah, just a little bit about myself. So let's get right into it. What increases your data platform cost? So when you look at your overall data platform cost, the data warehouse today is typically the largest line item in your infrastructure. We typically see, again, this varies based on companies, but we typically see your data warehouse is about 40% of the cost of your entire infrastructure. So entire infrastructure bill, assuming it's about $100,000, about $40,000 goes to the warehouse. Typically, we see ingestion tools make up for about 20%, BI makes up for 20%, modeling, orchestration combined about a 12%, and 8% others. Now, this sort of surveys Series A companies and above. You have a lot of large enterprise businesses over there, which are buying all sorts of other tools like governance, catalog, observability, security. A lot of these are sort of clubbed in. But at a macro level, if you were to basically go sort of bucket these, the largest line item which we see is typically your data warehouse cost. So as we think about data platform cost optimization, optimizing data warehouse cost is usually it's got the highest return on investment as well as it's the lowest hanging fruit. We typically see that optimizing these warehouses is no longer trivial. Just like making a post on Instagram isn't going to make you a marketing company. A few optimization queries on your data warehouse isn't going to make much of a difference. We've seen that Redshift is the most complicated. It can be the most performant data warehouse. The way I describe it is like Redshift is a 1970 Ford Mustang. It can be tuned and a it's it's a beautiful piece of engineering. However, it requires a lot of expertise to be working in the right way. Snowflake is typically the easiest. It's like buying a Prius. You sort of get in the car and you drive. There are a ton of tools out there which do cost optimization. They do a bunch of things in terms of explain plan for your queries, in terms of being able to set up different types of warehouses, monitor usage across that, automatically shift, make sure you're taking advantage of all of the optimizations sort of required. We won't get too much into that. There's a tool which we really like, which works really well for Snowflake. It's called Select. It gives you sort of Ian, the founder, posts a ton of stuff online on resources on how to sort of focus on Snowflake cost optimization. We think these are great resources. We think in general, sort of data warehouse optimization is a topic which is quite widely spoken about. So we didn't want to spend too much out there. We just wanted to sort of mention that warehousing is the biggest line item on your warehouse. So optimizing this makes a ton of sense. We have a bunch of buyer's guides with 5x, which give you much deeper insight as to which warehouse you want to pick, what ingestion tools make sense for your business, what BI tools make sense. Again, ingestion, BI, warehouse end up being the three biggest categories. So this typically is about between 60 to 80% of your entire bill is just these three different categories. So we have a buyer's guide which gives you detailed information as to how some of these tools s- stack up against each other. Also from a costing perspective to see how you can optimize some of these spends. The second area which we've seen, which results in data platform costs ballooning, is this concept of capability duplication. What's happened is that as what the modern data stack version one was really about was was best in breed tools across individual categories. The five core categories: there's data ingestion, there's warehousing, there's modeling, there's orchestration, there's BI, and each of these categories typically had a best in class tool. What's happened is as data costs have started to be analyzed and zoomed into more, we're finding that individual vendors are going into adjacent categories. I want to give three examples with data modeling and data orchestration. Some of the most powerful tools inside data modeling, uh, at the moment, DBT is all the jazz. Um, a lot of companies are using DBT as their modeling layer. If you're using DBT, your chances are you're probably also using DBT Cloud or DBT Enterprise. Now, DBT Cloud and Enterprise come with their own orchestrators, so they have an inbuilt orchestrator which you can use to go model jobs. Now, this is great, and DBT is the most popular sort of data modeling tool. What tends to happen is that DBT is typically used for your SQL and for your basic Python jobs. However, as these companies are now advancing into data science, they typically need to have more advanced orchestrators, maybe Airflow, maybe Dagster, maybe Maze. Some of these other orchestrators exist for more complicated DAGs or for more advanced use cases. And what we tend to see a lot is duplication of capabilities. You have an orchestrator inside your modeling layer, inside EVT Cloud, but you also have one outside. Not only is this obviously more expensive because one way or the other you're paying for duplicate capabilities, but also uh, a big factor is teams start using both of them. So some jobs exist on DBT Cloud. We have some jobs which exist out of it. This makes organizing jobs more complicated. It's harder to find. As a result, this results in decreased productivity. And we see the capability duplication problem start to uh, make things a lot more inefficient and hence slow teams down. We see this in data ingestion and modeling, Fivetran being the de facto data ingestion tool out there. Fivetran now supports pipelines which can actually not just uh, extract and load the data, but do an element of transformation inside the pipelines as well. Now, this is a great capability. Again, we see companies who typically have a modeling tool like DBT and a tool like Fivetran. You have the capabilities to now model the data across both of these places. One of the big fears around this is, part of the team uses one tool, part of the team uses other tool, and this leads to all sorts of duplication of logic, as well as it makes it harder to organize. A lot of BI tools now allow you to directly pull from data sources. Very typically, this has been done for convenience to allow businesses which don't have a fully fledged data platform to start to go analyze some data directly into a BI tool. BI was one of the first categories. So having BI tools which are building ingestion capabilities has always kind of existed. It's becoming a little bit more popular now with tools like Tableau, tools like Power BI able to basically do ingest data directly from different data sources and analyze this inside the BI tool. Again, a lot of duplication of logic because the way data platforms typically are set up is you have a separate data ingestion layer that goes into a warehouse. you have a separate sort of modeling layer. So this results in, having multiple different ways of doing things. Also, you have BI tools like Looker, which have their own data modeling layer. So LookML or the semantic layer is now starting to become something which is being adopted by more and more BI tools. This starts to become this contention of resources. Is modeling supposed to be done inside a separate modeling layer, which can be called a business layer? Or do you want to have your BI tools read directly from your raw data and actually go build their own semantics and then allow you to slice and dice that? There's serious repercussions of doing it inside the BI layer, mainly being is that data is not available in the warehouse for analysis, for reverse ETL, for AI. It exists solely in the BI layer, which becomes a problem. And if you then want to use it for analysis or reverse ETL or AI, you need to remodel this over there, and that causes what you call a fan out problem. So these are some of the inefficiencies which we're seeing around capability duplication. This tends to have um, an impact towards productivity, towards sort of standardization, which in turn, we see can decrease productivity anywhere from 5 to 15%. Moving on, um, a cost inside one of the largest cost factors inside a company's entire data strategy is people. Very typically, you see for every $1 spent on data infrastructure, you see between $5 to $15 spent on people. So data platform teams, which are the ones which are actually building your data infrastructure, end up being a large cost factor. We typically see that data platform teams are about 20% of the size of data teams. Um, and what data platform teams focus on are areas like vendor discovery, vendor selection, integration, access control, governance, security. These are typically the job functions of your data platform team. Um, they work on integrating multiple different layers of the stack. This was extremely relevant inside, what was called the modern data stack era, where you had best in breed vendors and you had data platform teams which would stitch them together. Case in point, at WeWork, when we had about 100-person data group, we had about 20 people building our data platform. So what people don't sort of realize is that, a company like WeWork was spending about $4 million a year, sort of taking into account, a sort of American salaries at the time, in order to go build a data platform, which wasn't particularly differentiated against the next company. Our use cases weren't that different from the next company that we needed to spend for $4 million on our data platform per year in order to go maintain this. So, probably one of the biggest sort of hidden costs in building out your data platform are the people costs of it. And, this typically sort of saving this cost has got a bigger impact on your data infrastructure cost than any single item on your data infrastructure bill. Um, Going deeper into this, build versus buy decisions, something which a lot of people don't realize in build versus buy decisions is this idea of the complexity tax of the complexity tax. I recently wrote a post on this, and really the way I think about the complexity tax is as you scale headcount, the efficiency of each team member starts to decrease. Uh, you know, between a 5 to like 15-person team, the sort of difference in efficiency starts to go down drastically. We think that about a 15-person team is at least 30% less efficient per person than a 5-person team. And at hundreds of people, this becomes nearly 50% of efficiency is lost. So for every two hires you actually hire, you actually start to get one hire. This is really important for the build and buy decision. It's something a lot of people don't really take into account, apart from all of the economics and maintainability and sort of everything else, is that choosing to build means that you are taking on more people, and having more people increases your complexity tax. Choosing to buy tools out there means you're able to actually be a lot more efficient with your people, and hence, the people that you have are actually able to work internally in a much more efficient manner. So, again, we sort of tend to see that the efficiency tax of building your own platform is something which is not obvious and one of those hidden costs which goes in building a data platform. Um, I want to go over some of the industry trends which we're sort of seeing, which in the long term are going to be very favorable in helping decrease costs. For those of you who've been paying attention to what's happening in the Snowflake versus Databricks world, I know somebody on the, I know Murtala on the webinar had a question of, how do you evaluate Databricks and sort of Snowflake? The reality of it is both of these tools really offer a proprietary compute layer, right? You're able to put data, in Databricks directly into AWS or Snowflake. It still goes into, S3 storage or, whichever cloud you pick, but it's fundamentally a proprietary compute layer on top of this. Now, these companies typically have had high margins on compute. Everything maps back into compute. They make life very easy. We think one of the most exciting thing inside the data world today is this concept of Iceberg. And what Iceberg really allows us to do is have a master storage layer. So we can move storage back into blob storage on on sort of flat storage. What that means practically is having your data actually reside in S3 and having these compute engines, which are Databricks or Snowflake or uh, Starburst, Redshift, GCP, Azure, all of these different engines will be able to read and write directly from your master storage layer. What that means is you can actually have multiple different compute layers on at the same time and accessing the same unified catalog. And what this is really going to allow is we're going to start to see a lot of lower cost compute layers coming inside 2025. So a lot of the proprietary compute layers like Snowflake and Databricks, which tend to be very expensive, those are gonna still continue, and they're gonna make a lot of enhancements, especially when it comes to things like data catalog, when it comes to things like AI. Snowflake is open source Polaris, Databricks is open source Unity catalog. So they're gonna build on top of the ecosystem to give customers a lot more value add apart from just plain compute, and they're gonna have to do that to go actually rationalize the margins which they make. What In parallel, what's going to happen is we're going to start to see a lot more cheaper compute coming. And because we now have a unified storage layer and we can choose, and any compute which we choose to run on top of this can read and write from this unified storage layer, we're going to have the ability to have some of our jobs on these proprietary compute layers and a lot of our batch jobs, which are not as important, you can choose to run on a different compute engine. We think this is really good for the consumer in the medium to long term. We think Iceberg is about a year away for mass adoption today. Playing around with Polaris, there's a lot of uh, early early teething pains where not being able to read and write into the same catalog, not being compliant with other compute engines and then being able to read and write, not allowing all data to be able to read and write into these compute layers. So, still very, very sort of nascent and early. And, given Databricks acquisition of Iceberg, it's going to be very interesting to see how this plays out. But, we think in about a year, we're going to start to see a ton of lower cost compute options, which are going to be sort of very favorable to sort of consumers. This came from a Gartner study, which we recently saw. This is talking about this is the hype cycle of sort of data management software, really where we're starting to come in at this point is sort of into third generation products. What we typically see over there, which is in line with what we're seeing in the sort of industry sort of day to day, is a next generation of products, sort of very much out of the box capabilities, a lot more end to end, a lot more product suites. We're seeing what we call the rise of, what I refer to as the second version of the modern data stack. If modern data stack version one, was the fragmented ecosystem with best in breed vendors like Snowflake and DBT and Fivetran and Looker. These were the signature sort of vendors of what we refer to as MDS V1. What MDS V2 is going to be a lot more is on out of the box, all in one platforms, which are able to give you everything out of the box, which don't require going back to what we said about the hidden costs inside the data world. They don't require you to have a data platform team. They don't require you to focus on building large teams. How these would really focus is, MDS V1 is what we would call the car part strategy. Imagine walking into a Honda, and then instead of selling you a Civic, they sell you an engine and you have to build your own car. Now, what we call MDS V2 is this concept of buying an end-to-end car. So in V1 you were buying car parts, and V2 you get out of the box components. What it gave you inside V1 is sort of flexibility. What this is now going to become is sort of productivity in the post, financial focused world. What you had is expensive contracts, so they buy multiple different pieces. Each of these teams which are buying has to maintain their own customer support and sales and product um, and sort of marketing groups. What we now see inside MDSV2 is decreased DCO and cost becoming a real factor in decision making. What we needed was large teams. We mentioned about 20% of your team is your data platform team, which is needed to go stitch this all together. What we're seeing inside MDSV2 are lean teams, which are able to do this with much fewer resources. What we had is individual vendors focusing on single capabilities. What we now are able to do is end-to-end workflows. When we stitch together multiple pieces, we're able to actually integrate them more than just the sum of their parts, but into actually end-to-end workflows. Uh, we had a lot of vendor lunches and happy hours. We sort of joke about, you know, being invited to sort of multiple different vendors, all of which are trying to pitch you. But, MDS V2 is a lot more about it's like getting stuff done. Um, what we're seeing all of this lead to is the rise of all-in-one data platforms. And we think that is already a big trend into where the industry is heading. All-in-one platforms have a ton of advantages out of the box. Things like instant setup, zero time on vendor discovery, end-to-end workflows, lower TCO, increased productivity, and security. There are a bunch of different reasons, advantages all-in-one platforms get to focus on, given our topic is a lot more around cost optimization. I will cover a few of them right now. One of them, which we really want to go into detail, we typically see about a 30% lower TCO. And what's very interesting on this is the lower TCO is not just on the infrastructure side. On the infrastructure side, we typically see, sort of on average, we're seeing about a 30% lower cost of TCO. Again, this makes sense. If you have a single vendor strategy, your vendors don't have to go have multiple sales teams, like a multiple vendor strategy, multiple marketing, multiple customer success, multiple customer support. All of this is consolidated. Ultimately, all of these increased costs or all of these savings are eventually passed back to the customers. We typically see between 30 to 35% lower costs just on the infrastructure level of using a single vendor strategy with an all-in-one versus a multi-vendor strategy. The bigger piece really is the saving on the data platform piece. As I mentioned, data platform teams are typically about 20% of the size of your entire data functions. And roughly speaking, for every $1 of infrastructure spend, you have between $5 to $15 of people spend. So at an average, this is about $9 to $10 sort of dollars spent for every $1 spent on infrastructure. So a 20% decrease in data platform size often is bigger than the entire spend on data infrastructure. So comparing, what is your lowest hanging fruit is to actually decrease the size of the team needed to go operate your data infrastructure. And the last piece we see over there is an increase in productivity. Namely, we see this because the multi-vendor strategy involves a lot of switching between multiple vendors on a daily basis. And we're able to get rid of large parts of this by, again, moving towards a unified platform strategy. For every $100 spent, again, what we've seen typically is in a build your own platform strategy, you're spending about $10 on infrastructure, $90 on people in all-in-one platforms. What this sort of models to is about $7 of infrastructure and $63 on people. So you see a large sort of reduction. You see about a 30% reduction in both, and and that maps to a sort of 30% sort of reduction combined. Um, it's one thing to, you know, at 5x, what we've been up to for a while, we've been, one of the early all-in-one data platforms. Today we have over 5 different capabilities. We have data ingestion, warehousing, a data modeling, a data orchestration, and a BI suite. So we have 5 different product strategies. The way it's really built is you can go use all of these products, or you can mix and match. So if you already have a data warehouse, if you already have a BI tool, you can bring those in. You can use us just for the missing pieces like ingestion, like modeling, like orchestration. Um, it's one thing to really, go sort of talk about this and understand this at a conceptual level. One of the big advantages of using an all-in-one data platform is that you're able to actually get started and build extremely quickly. So what we typically see that it takes companies between 4 to 6 months to go build a platform and to go get started on your use cases. By having an end-to-end platform and having all of this together, we're able to do this exponentially faster. So what we've introduced is this concept of a 48-hour jumpstart program. And what we're able to do on this program is to actually take an end-to-end business use case and actually go build this out. So we can take a business use case. This could be visibility into your marketing funnel. This could be things like building out adoption of a product, and actually go build this out end to end. What does end to end mean? It means being able to pull data from your different data sources into your warehouse, model, clean, structure your data, have it orchestrated, and then build it out inside a BI layer. We're also doing things like pricing forecasts across your entire data footprint, and then some roadmaps and recommendations. So what we're very excited to actually show you is, a process which would typically take companies 4 to 6 months. We're able to now go do this in sort of 48 hours for customers. And what we're going to do for, our first, we're just about to go launch this sort of 48-hour POC process. What we're about to do is we're going to open this up for people on this webinar. We are also going to be sort of launching this over the next few days. For the first 5 people who sort of go to our website and sort of sign up, we're going to offer a free jumpstart package. So, just come to us with a use case. We're going to actually build this out end to end on the 5x platform completely for free. This is typically something which we're going to charge about $2,500 for. And we would love to sort of open this up for this group. So very simply, to sort of go qualify, all you need to go is visit 5x.co/jumpstart, go fill out the form, book some time with us, and we'll give you all of the details on the Jumpstart package, and helping you to actually go see what this looks like end to end. With that, would love to open it up to questions.
Tarush, we have a question from Bimal, and he's asking about, I want to know how to optimize cost while running in BigQuery.
That's a great question. BigQuery is a little bit different from Snowflake. BigQuery works on this concept of slots. So BigQuery optimization can be a little bit tricky. We actually have experts who focus just on BigQuery cost optimization. If you reach out to us, just sort of book some time over there. We will connect you with one of our solutions engineers who focuses purely on sort of BigQuery cost optimization. We do a ton of projects on sort of helping customers over there. Again, we'll be happy to share just some of the macro level overall tactics which we use for BigQuery. Again, they're very specialized. The Snowflake world doesn't really apply to them. So just sort of reach out to us separately, and we'll be happy to share that.
Yep, that's about it. If anybody has any other question, the chat is open.
If anyone has any questions you don't ask me sort of separately, you can connect to me on my LinkedIn. My profile is just Tarush Agarwal. Like also email me. My email is tarush@5x.co. We would love to hear from you. This is the first time we're doing this webinar series. We intend to do one per month. Really appreciate everyone joining. And if anyone is interested in the Jumpstart, we're super excited about this. This is something which, seeing a demo is one thing, but actually going and seeing your data end to end live on a platform is something else. Looking forward to hearing from you, and everyone have a wonderful rest of your day.
Thanks, thanks everyone for joining. Bye.